we're going to look at proving the sum to n terms formula for arithmetic progressions. So this is a C1 skill, something you might need to be able to repeat on a C1 paper. So what we start off with is we just write out the standard sequence as algebraically, as generally as possible. So the first term, we call that A. So I'll just start with that. The next one, remember, sum to n terms, so I'm going to add them together. The next one has one common difference added on, so A plus D. Then I would add on another one and get to A plus 2D, and then I would carry on and a few more. Right, that just shows however many that I need. The last one, well, I don't add on n lots of D, because this first one doesn't have a D, doesn't have a common difference. It's the first one. So the last term is actually A plus n minus 1D. Now the trick to this whole proof comes from this second step. What I do now is I add the sequence back on to itself, but I don't repeat it, I write it backwards. So this time I'll start off with that A plus n minus 1D. Okay, I'm just going to add these together. Now the one before that, I suppose, is A plus n minus 2D. Okay, and just keep going in that sort of way. A plus n minus 3D. Right back to the beginning of the sequence, which would of course be A again. So just write all this out in this very general way, using A's and D's and N's. Now, if I added these two bits of information together, I'd have two lots of this sum. So I would have 2Sn. At this stage, each one of these actually comes out to be the same thing in this sort of column arrangements that I've made here. I have A plus A, which gives me 2A. And for this first one, I have n minus 1 lots of D. This next one, I have 2 A's. And then I have, it's tricky to think about, n minus 2D plus 1D. Which, if you think about it, actually gets you back to n minus 1D. This happens all the way along. They all turn out to add together to make another 2A plus n minus 1D. Right, we're much closer now. Just need to find out how many of these we've got in the line. Well, we started writing out in a very general way n terms. That's how many we were supposed to have. So there will be n lots of 2A plus n minus 1D. So we'd end up with that. Notice the square brackets, the formula really coming together now. We are so close. The last step, of course, this gives us 2 lots of the sum to n terms. We only need 1 lot, so divide everything by 2. And there we have it. So, just to recap, we wrote out the sequence using the sum to n terms, using the most general terms possible. The A for the first value, and the d for the common difference, the thing that we add on each time. We go all the way up to a plus n minus 1d. Underneath, this is the key step, add on the sequence again, add the sequence back to itself, but with the terms reversed. Because the effect of that is, first of all, you've got two lots of the sum to n terms, but then each term is 2a plus n minus 1d repeatedly. Then you say to yourself, I'll have n lots of 2a plus n minus 1d, so reduce it to that, and then just divide both sides by 2 to get the formula.